Hi, my name's Pete Rowley and I'm Senior Lecturer in Geology at UE Bristol. Welcome to this refresher on landslides. So landslides are particularly interesting for us in the UK because they're considered one of the biggest hazards in the UK. And there's lots and lots of different types, and we can classify them according to a number of different schemes and characteristics. So we can classify them according to the type of material involved, the type of movement they undergo, the speed of that movement, the volume of material, and the destructive impact. So if you do find classifications of landslides which disagree with what you thought you were aware of, it's probably because that scheme is using one of these different modes of classification. So here's a image which just gives you some of the main terminology to describe landslides in the physical characteristics of landslides. So the main features that you will tend to find are the crown and the main scarp. You then have the head of the landslide, which is the top surface of the material that's moved, moving down through the body of the landslide to its foot and then the toe, which is the very tip of the front of the landslide. Underneath the body of the landslide, you have the rupture surface, and the surface deformation on the landslide itself can often be cut by things like transverse cracks or transverse ridges or radial cracks, depending on the way this landslide's moved and the kind of material that has moved. When talking about the risk posed by landslides, one of the most important things to consider is what's called the factor of safety. And this is a very simple calculation that gives you an idea of what the threshold is of whether a landslide occurs or not. So very simply, the factor of safety can be calculated by looking at the shear strength of the material involved and the shear stress that is being applied to it. And as long as the shear strength is greater than the shear stress, then the landslide isn't going to occur. It's only once the shear stress becomes so great that the strength of the material is exceeded that a landslide will occur. So the driving factors in terms of shear stress, big components of this are the weight and the density of the mass of material that's going to move, the material properties of it, and gravity. Because obviously gravity is the main driving force behind this. The weight and the density are all contributing towards how gravity is going to move this material down slope. In terms of the resisting factors or the shear strength, friction and cohesion are the two main components here. And these are going to be affected by lots of different processes which could be happening within the rock or the soil involved. So we could be talking about chemical weathering, which breaks down some minerals into clays. We could be talking about having more water in the system, and when you have water, that increases the fluid pressure and the mobility of this material. We could have undercut the slope, which reduces the mechanical strength of the material. Or we could have vegetation, and vegetation can both act to stabilize slopes, or root penetration and biological weathering can actually induce landslides by weakening slopes. We can also then have external events like earthquakes, which can rapidly weaken or trigger failures in systems which were otherwise still stable. And when we're talking about landslides, moisture is very often the key to whether a landslide happens or not. So the conditions for a landslide will evolve over potentially decades, maybe even centuries or millennia. But that moment when a landslide occurs usually needs some kind of triggering factor. And this triggering factor is very often moisture. So we have some diagrams here showing the different systems that grains in a solid undergo depending on the water condition. So without water, all you're relying on is the weight of particles upon each other. And as a result of this, your contact friction between those grains is the controlling factor. Now, if we add some water, just a little bit, so that we moisten the edges of those grains, what also now takes part is surface tension. So the water adds strength to the material. However, if you add more water than that, if you start increasing the amount of water between grains, the surface tension gets broken, and now you start forcing the grains apart so that the contact friction can't work either. So as a result, you then end up generating flow. So by adding too much water to a solid, we can start weakening it. Now this is particularly looking at the case of granular solids, so things like sand or gravel or muds. Obviously in rocks the situation is a bit different, because quite often there's all sorts of cement and other things holding that material together. But this is a simplified example, and you'll all be familiar with this in reality because it's the same thing that means sandcastles work. If you're going to make a sandcastle that has nice steep sides, you know that you want to be using ever so slightly moist sand. If you make it with very dry sand, you just end up with piles that maybe have 30-degree slopes on them. Once the tide comes in and we start adding more water to that, it very quickly starts breaking sandcastles down, because we now have excess water that's reducing the ability of the contact friction and the water surface tension to hold the castle together. So this is a common classification of landslides, looking at the type of movement. So we can talk about falls or topples, rotational slides. We can have translational slides which move sideways. We can have lateral spreads, flows, or complex, where we have one or two or more of these things occurring at the same time. And we can also classify by the type of material being involved. So we can think about solid bedrock, we can think about debris, or we can look at what's called earth, which is finer grade soils. And then we can combine each of these criteria together to give a more precise naming convention of different types of landslides. So if it's a bedrock which is falling, then that's a rock fall. If it's a debris material which is undergoing lateral spread, then it's a debris spread. And if it's a fine soil which is rotationally sliding, we can call that an earth slump, and so on. A different categorization system we can use is to classify these things by the severity of their impact. So we can look at these things as being catastrophic, intermediate, or sluggish. So this is using 4 parameters, the class, which is given a numeric value. We have the description, which is based on the kind of speed of movement. We have the velocity limits, which are the actual speeds, and then the destructive impact that is generally associated with these types of flow. So if we start with the sluggish, we start down at class 1, which is extremely slow, with velocity limits on the order of meters per century. And the destructive impact of this is that the movement is really perceptible only by instruments, and as long as you're aware that that motion is happening, you can actually take precautions to allow it. This kind of motion, however, can impact structures which already exist, so you can have catastrophic damage caused to buildings by this kind of movement, but you're going to have time to prepare for that and mitigate against it. As we come up through this system, we get faster and faster until we're into the moderate period, where we might have meters per week of movement, or perhaps as much as meters per hour. As we come up into the intermediate damage landslides, we're into rapid and very rapid, where we're perhaps talking about meters per hour to meters per minute, or meters per second even. And this is where you start to have potential for loss of life, because these rates of motion are too fast to give warning or evacuation opportunities. And then finally we get to catastrophic, where we're potentially looking at movement in the order of 5 to 50 meters per second. And these are situations where actually, even if you're there, even if you haven't got warning, you're very unlikely to be able to escape, even if you start to feel the motion, because the speed of the landslide is actually faster than you can move. This is very definitely going to be destroying buildings and causing a lot of damage. So as an example of one of these catastrophic landslides, we had a really good example earlier this month in Alta in Norway, and this is what's known as a quick clay landslide. So quick clay is a clay that's deposited in a marine setting. It's deposited under seawater, and as the clay forms, you end up with salt crystals forming within the structure. And if you add too much fresh water, that fresh water can remove the salt, and this salt that had been crystallized and holding some of this clay together, as it's removed, the clay weakens. Now, Norway is very aware that it's got quite a lot of quick clay in different places, and as such, there's been quite a lot of assessment of the issue and the possible hazard areas. And this map is showing you the quick clay risk areas for this location in Norway. And as you can see, the hatched areas around Talvik and Melsvik are identified risk areas for these quick clay landslides. However, that arrow is showing you where this landslide actually occurred. So it's outside the identified hazard area. So even though we can do the best risk analysis we can, sometimes things do get missed. So this video is from VGTV, and it shows what happened during this landslide. This was the very early stages. It was captured.
Flere bygninger og en hund ble skylt på sjøen etter flere jordras på Kråkneset i Alta onsdag. Her ser vi øyeblikket hvor jordraset tar med seg et helt landområde til sjøs. Operasjonsleder Torfinn Halvari opplyser klokken 19 at skredet skal ha vært mellom 500 til 600 meter langt og 40 meter høyt. To personer ble evakuert fra området av frykt for nye ras, men det er ikke meldt om personskader. En hund som ble tatt av raset har selv klart å svømme i land. Det har blitt søkt med både redningsskøyte og redningshelikopter etter mennesker i vannet. Politiet opplyser at ingenting tyder på at noen personer er tatt av raset. Distriktsingeniør Anders Bjordal i NVE sier at det er et kvikkleireskred som har gått. Regionsjef i NVE sier til VG at det ikke er fare for liv og helse per nå.
By a video crew, and they managed to see what happened.
Flere bygninger og en hund ble skylt på sjøen etter flere jordras på Kråkneset i Alta onsdag. Her ser vi øyeblikket hvor jordraset tar med seg et helt landområde til sjøs. Operasjonsleder Torfinn Halvari opplyser klokken 19 at skredet skal ha vært mellom 500 til 600 meter langt og 40 meter høyt. To personer ble evakuert fra området av frykt for nye ras, men det er ikke meldt om personskader. En hund som ble tatt av raset har selv klart å svømme i land. Det har blitt søkt med både redningsskøyte og redningshelikopter etter mennesker i vannet. Politiet opplyser at ingenting tyder på at noen personer er tatt av raset. Distriktsingeniør Anders Bjordal i NVE sier at det er et kvikkleireskred som har gått. Regionsjef i NVE sier til VG at det ikke er fare for liv og helse per nå.
So as you can see from this video, so could this event have been prevented? Well, quick clays can be solved. You can chemically stabilize them by injecting something called potassium chloride. And this essentially replaces the salt in the quick clay and makes potassium chloride isn't water soluble, so it's stabilized for freshwater ingress. The problem is this is expensive. It's also quite difficult to get that material into the clay, and there's no guaranteed success. You can't guarantee that you have managed to remove all of the salt from the quick clay, so you don't know that you've actually solved the problem. More importantly, you can only mitigate these risks if you've identified the risk, and in this particular case this had not been identified as an area at risk. So if you want to look for more resources on landslides, there's some fantastic information at the BGS on these links here, as well as the US Geological Survey. If you've got any questions or comments or queries, please do feel free to get in touch with me on the details here. These catastrophic slides can be very large scale and very devastating very quickly. In this particular case, my understanding is that there were some cracks had started to form up near the head wall, and so this area was evacuated. There were no fatalities. But there's a few interesting features that this example shows, particularly because this camera person was able to get set up to capture this so well. The first is the scale of this landslide. It's hundreds of meters across, and it fails down into this body of water, and one of the things it generates is I'm reluctant to use the word tsunami, but certainly there's a lot of backwash water which comes back in, so the coherent lump of land which had houses moving along on it was the backwash of water which started washing these houses away, causing the damage, and eventually washing back up onto the shoreline to start impacting areas which actually hadn't been affected by the initial landslide. So this is just a really kind of nicely captured example of a really devastating event for a community who were not aware that they were really at landslide risk.